How did that be recorded voices outside?
It does, as long as you have the microphone on. All right, so this is lesson 6.9, day 2. And this is going to be U-Substitution. For definite integrals. So Wednesday's lesson, we did U-Substitution for indefinite integrals. What is the difference between definite and indefinite integrals?
We have x values.
You have the upper and lower limits, yes. So when you're finished with a definite integral, you just have a number as your answer. You don't have an expression. What do you have to remember to add on to the end of the indefinite? Plus c. All right, so you can't forget that because you're finding the antiderivative. So you have to make sure you have that plus c. All right, so the difference is between what we did Wednesday and what we're doing today is kind of like the last step. So to complete most efficiently, and that's what we want to be, is efficient. I think it's a good idea to write the upper and lower limits in terms of u. Now that will not be a hard step. It'll be like taking the number and squaring and adding 1 to it or something like that. It will not be a hard step. All right, and then if you do that, if you write the upper and lower limits in terms of u, you're also going to leave the antiderivative in terms of u. So then leave the antiderivative in terms of u. Oops. When applying the fundamental theorem of calculus, or the FTC. Yeah, so I'm going to say a lot of the same things. We just have a little extra weird things in the middle. All right, so our directions for all of our examples are to evaluate. All right, for A, we have the integral from -1 to 1 of x times the quantity x squared plus 1 quantity raised to the 4th dx. Now, one thing that you're going to get better at is just kind of recognizing when you have to do U-substitution and when you don't. So that's going to be kind of what the whole lesson is going to be on Tuesday, is like deciding what to do. So this one is a U-substitution problem because we have an inside function. What do you guys think the inside function is? Good. That's going to be u, x squared plus 1. All right, then we'll go ahead and find the derivative of that and solve for du. So what is our integrand missing to have all of du? It's missing a 2. So let's go ahead and take care of that. So we're going to multiply the integrand by 2. So what do we have to multiply outside of the integral? 1/2. Nice job. All right, and I'm going to rearrange this a little bit. If you don't have to rearrange it to be able to write it in terms of u, it's fine, but I think it kind of helps the beginning. So I just move the x to the back. We multiply by 2. So we have our du all together. We're gonna change our integral to all u's and no x's. So right now, our upper and lower limits are x's. So we have to change them to u's. So we're gonna take -1 and we're gonna plug it in to u. And then it's gonna be a u and not an x. So that means we're gonna square it and add 1 to it. So our lower limit is going to be 2. All right, we'll do the same thing with the upper limit. We have to change it from an x to a u by squaring it and adding 1 to it. It is going to be 0, yes, good job. I'm going to finish writing it in terms of u and then we'll talk about that. So how would you write the integrand now in terms of u? Good job. Now, if you guys notice, the upper and lower limits are the same, and that is a property that we actually talked about on the video. I didn't actually teach that to you in person, I guess. So it's like you're trying to find the area under the curve, but there is no width. So that area is going to be 0. There's no area because there is no width. So anytime your upper and lower limits match, that integral is 0. You don't have to do anything else. All right, so let's do some where you actually solve the problem all the way through. So for B, we have the integral from 0 to 2. We have a fraction. The numerator is x squared, and the denominator is the square root of x cubed plus 1, and then dx. All right, so this is another one that is, we're gonna need to use U-substitution. So we have an inside function, and then we basically have the derivative of the inside function in there, kind of. So what would you guys say u is? Good. All right, so du is gonna be 3x squared dx. All right, so you guys take your integrand, please, and correct it, I guess. So rewrite it so u is there on the inside, please. All right. So now I'm going to take the whole thing and rewrite it with u, including the upper and lower limits. So I would take 0, plug it in to u, so cube it and add 1 to it. Take 2, plug it in, cube it, add 1 to it. Right? And then this 3x squared dx is du, so I'm just going to write it on the numerator. Right. And then for the denominator, instead of writing the square root of u, is there another way I can write that? U to the 1/2. Good. Now when it's in this form, I can't really find the antiderivative. So if I want to write that u in the numerator, what would the power be? -1/2. Nice job. All right, so take a second, look at everything we did, make sure it's all making sense. So a lot of calculus mixed in with a lot of algebra going on in this problem. All right, We're ready to find the antiderivative. So that 1/3 is going to hang out for a second. We're going to add 1 to the exponent and divide by that. So what do we get when we add 1 to the exponent? 1/2. And what do you get when you divide by 1/2? 2. Multiply by 2. Right, and then I still, even though I've been doing this a long time, I still, after I do, and especially with the fraction exponents, I still will find the derivative in my head just to make sure that you do get u to the negative 1/2 when you find that derivative, just because it feels a little awkward.
Wait, how did you get 2u to the 1/2?
Okay, so the antiderivative, you add 1 to negative 1/2, and you get 1/2, and you divide by that. So dividing by 1/2 and multiplying by the reciprocal mean the same thing. All right, and then be careful on your notation. And this is new notation. So when you're finding a definite integral, after you find the antiderivative, you kind of do this big bracket, and you put the lower limit at the bottom, and you put the upper limit at the top. And then we're going to go ahead and do the fundamental theorem of calculus, where we plug them in. Now, it matters what order you plug in. So which am I going to plug in first? The 9. The upper limit goes first. Now, one thing I can do, just to save on time, that too can get pulled out. So we'll have 2/3 hanging out there. You don't have to do that. It will just save you a little bit of time. So we're going to plug 9 in for u. It's going to be 9 to the 1/2 minus 1 to the 1/2. Or the square root of 9. The square root of 9 minus the square root of 1. What is that going to give us? 3 minus 1, right? Oh, so 2. Sorry, I didn't hear that. So eventually we end up with 4/3.
So whenever you do the antiderivative of the u to the negative 1/2
Mhm.
du, where does the du go?
When
Why
you
don't we do a plus c?
Okay, when you do indefinite integrals, you do plus c. When you do definite integrals, the c doesn't matter because we are subtracting that. I mean, if you did plus c and then subtracted, it would subtract away. You know what I mean? So I talked about this right at the beginning. So definite integrals, you do not do the plus c because it really doesn't matter. It will subtract away no matter what. All right, any other questions? And when you take the antiderivative, it absorbs the du. So on all of the antiderivatives we have done from the beginning, once you take the antiderivative, whether it's indefinite or definite, it doesn't have the du or the dx anymore. Okay, let's do a couple more. So for c, I have the integral from 0 to pi of 2, I'm just kidding, sorry, cosine of 2x dx. So you guys, on your own, find u and du for me, please. So what's our integrand missing? A 2. So we're going to have to multiply by 2 on the inside, so we're going to multiply by 1/2 on the outside. All right, and then we're ready to go from x's to u's, so everything is going to change. So 2 times 0 is 0. 2 times pi is 2 pi. And then in the place of 2x, we're going to write u. And in the place of 2 dx, we're going to write du. So what is the antiderivative of cosine of u du? Sine of u. Okay. And then we're going to plug in our upper and lower limits. All right, so we'll start with 2 pi. What is the sine of 0? 0. Oh, what's the sine of 2 pi? Also 0. They fall in the same exact place on the unit circle. So 1/2 times 0 is just going to be 0. All right, are you okay? Okay, I have one more. This one is kind of tricky. So for D, we have the integral from 1 to 4, and we have another fraction. Our numerator is the quantity natural log of x quantity squared. Our denominator is x. I think you might have had one kind of like this on your worksheet. I can't really remember, but it feels like most of the time when we have these fractions, the u comes from the denominator, but this one it does not. So what do you guys think the inside function is? The natural log of x. What is the derivative of that? 1 over x. So this one is very different. So if you do it wrong and you decide what you say u is something else, and then it doesn't work out, then try another function as your u. And you're gonna get to a point where you're just gonna see natural log of x in your head if it's in the problem, and know the derivative of it, and check to see if the derivative is also in the problem, and this will get easier as you go through. All right, am I missing anything in my integrands? I am not, so it's all there. So we're ready to go ahead and write this in terms of u. All right, so what's your lower limit gonna be in terms of u? The natural log of 1. Your upper limit is the natural log of 4. All right, what about your integrand? Good, u squared du. That takes care of everything there.
Wait, what's the natural log?
Because the natural log is u. So when we write u, we're writing natural log of x.
I think about that. So if there's something that doesn't fit in, like of the x, you don't replace that with anything, it just disappears?
It didn't disappear. This, are you talking about this x?
Yeah.
This x is in du. Nothing disappears. It's just rewritten. It's substituted.
Crazy.
It's totally crazy. All right, so now let's do the antiderivative of u squared du. Oh, I don't need to rewrite that, sorry. So we're going to add 1 to the exponent and divide by that, and then the new exponent. So what do y'all think? 1/3 u cubed. All right, we are going to plug in the natural log of 1 and the natural log of 4, not in that order, the other order. So constants don't have to be used in the plug-in of each part. So I always, just to save on time, especially if it's a non-calculator question, and most of these are going to be, just pull that 1/3 out in the front. And then we're going to cube natural log of 4. And then minus, we're going to cube natural log of 1. Now there are tons of logarithm rules that you guys are gonna need to remember. And one of them is what the value is of the natural log of 1. What is the base of the natural log? E. So e to what power gives you 1? 0. The natural log of 1 is 0. So we technically have the natural log of 4 cubed minus 1, which is the natural log of 4 cubed. Did I say minus 1? I meant to say minus 0. Sorry. Minus 0 cubed. This is it. Now be careful also on the rules, because there is a power rule that a power on your argument you can move in the front, or you can move from the front to that. This is not on the argument. This is the whole natural log being cubed. So this is it. This is all we can do. All right. Any question? U-Substitution? Okay. Let me give you guys, your assignment you already have. So your 6.9 day 2 worksheet is the back side of the worksheet that I gave you on Wednesday. I just want you to finish it. So 13 through 22. And it's going to be a 10-point grade on Tuesday, which is the next day we're in class.
13 through 22.
Wait, the next day class is when?
It is the whole thing, isn't it?
Yeah, but not very good.
The whole thing is the grade. I see what you're saying. The whole worksheet is a grade.